Hey there, space explorers. Have you ever found yourself gazing up at the star-studded night sky, your mind brimming with questions? Questions about those twinkling stars, the serene moon, and the mystery shrouding the universe beyond our reach. Have you ever wondered how we, as humans, have managed to penetrate this vast expanse and send rockets piercing through the sky, reaching the very edges of outer space? Yes, rockets! Those magnificent machines that defy gravity, that roar and blaze a trail of fire as they ascend, leaving us all in awe. What are they? How do they work? What powers them? And how do they overcome the relentless pull of Earth's gravity to conquer the final frontier? If these questions stir a sense of curiosity in you, then you're in for a treat. Today, we're going to take a thrilling journey to understand the fascinating world of rockets and how they reach outer space. A rocket is a tall, thin vehicle that can travel into space. Picture a giant pencil, but instead of lead and eraser, it's packed with scientific marvels and powerful fuel. Now, you might ask, why is it tall and thin? The answer lies in the realm of physics and engineering. You see, a rocket needs to overcome Earth's gravity, and a sleek aerodynamic design helps it do just that, with less air resistance to fight against as it ascends. Now, let's delve a bit more into the peculiarities of rockets. Unlike cars which trundle on roads or planes that soar through the air, rockets operate in an environment that's nothing like we have on Earth. It's a place devoid of air, roads, or anything else that we're used to: space. And this is where rockets truly shine. They carry everything they need with them: the fuel, the oxygen to burn that fuel, and even the scientific instruments or astronauts they're tasked to carry. Rockets are a bit like self-contained cities. They generate their own power, have their own life support systems, and even manage waste. All these systems are tucked neatly into the rocket structure, each playing a crucial role in the mission's success. The design of a rocket is no accident. It's the result of years of scientific experimentation, countless failed attempts, and eventual triumphs. The shape, the materials used, the arrangement of various parts, each aspect is meticulously planned and executed. So, the next time you see a rocket, remember, it's not just a tall, thin vehicle. It's a testament to human ingenuity, a marvel of engineering that carries with it the dreams and aspirations of our species. Unlike cars, which need roads, or planes, which need air, rockets carry everything they need with them. This is because space is a vacuum, which means there's no air or anything else for regular engines to work. Imagine trying to blow up a balloon and then letting it go. You've probably done this at a party or just for fun. The balloon zips around in all directions, right? This is because of the air rushing out from the balloon, creating a force that sends it darting across the room. Now let's take this concept to a much grander scale. Yes, you've guessed it, we're talking about rockets. Rockets, in essence, work similarly to that released balloon, but instead of air, they use rocket fuel. This fuel is the powerhouse, the driving force that propels these magnificent machines into the vastness of space. Now you might be wondering, how exactly does rocket fuel work? Well, when the fuel is burnt, it produces an enormous amount of hot gas. This gas doesn't just vanish into thin air, instead, it's pushed out from the bottom of the rocket at high speeds. This is known as thrust. It's the same principle as the air rushing out of the balloon, but on a much more powerful scale. The thrust, or the force from the hot gas pushing downwards, is what sends the rocket upwards. It's like a massive, fiery push that propels the rocket off the ground and into the sky. This is Newton's third law of motion in action. For every action, there's an equal and opposite reaction. The action here is the hot gas rushing downwards, and the reaction is the rocket surging upwards. But it's not just about getting the rocket off the ground. The burning of fuel continues even after liftoff, providing the continuous thrust needed to propel the rocket further and further into space, past the Earth's atmosphere. So, the next time you watch a rocket launch, remember the balloon. That massive pillar of fire and smoke you see is really just a supercharged version of letting a balloon go and watching it zip around. And it's this force, this powerhouse of energy, that sets the stage for the rest of the rocket's journey. This force sends the rocket upwards. Rockets need a lot of power. Why? Well, let's dive into that. The primary challenge rockets face is Earth's gravity. Imagine gravity as an invisible hand, always pulling things towards the Earth's center. It's the force that keeps us grounded, quite literally. It's what ensures your morning coffee doesn't float off the breakfast table and why we don't drift off into space. But when it comes to launching rockets, gravity is the ultimate foe. It's constantly pulling the rocket back towards the Earth, trying to keep it from venturing into the cosmic beyond. Every second a rocket is in the air, gravity is working against it, pulling it back down. Picture a game of tug-of-war. On one side, you have the rocket, powered by its engines and fueled by its propellant, straining to ascend. On the other side, you have gravity, relentless and unyielding, pulling the rocket back towards the Earth. The rocket's goal? To pull harder, to fight against that invisible hand, and to break free from the Earth's gravitational pull. To overcome this colossal force, rockets need to achieve a blistering speed, known as escape velocity. This is the minimum speed an object must have in order to break free from a planet's gravitational pull. For Earth, this speed is a mind-boggling 25,000 miles per hour. Yes, you heard that right. To escape Earth's gravity, a rocket needs to travel at a speed 25 times faster than the fastest car in the world. It's like running 100 meters in less than a blink of an eye. That's the speed we're talking about. Rocket engines achieve this by burning their fuel in a controlled explosion. This releases a tremendous amount of energy, which propels the rocket upwards. The faster the fuel burns, the faster the rocket ascends, and the better its chances of overcoming gravity's pull. To get to space, rockets need to go super fast and break free from this pull. It's a monumental task, a testament to human ingenuity and the power of physics. So next time you witness a rocket launch, remember the immense battle it's waging against gravity just to reach the stars. Have you ever noticed how rockets are made up of different parts that look like separate sections stacked on top of each other? This isn't just a design choice for aesthetics, but a clever engineering solution that is integral to a rocket's journey to space. These separate sections are known as stages, each with its own engine and fuel supply. Fascinating, right? But why is this necessary? Why don't rockets just carry all their fuel in one big tank? Well, the answer lies in the concept of efficiency and the battle against gravity. Remember, rockets need to break free from Earth's gravity. To achieve this, they need to be fast and light. Carrying all the fuel in one big tank would make the rocket heavy, slowing it down, and requiring even more fuel to lift the extra weight. That's not very efficient, is it? So instead, rockets use a stage-by-stage approach. The first stage at the bottom ignites first. It provides the initial thrust to lift the rocket off the launch pad and starts the journey towards space. Once its fuel is depleted, this stage detaches and falls back to Earth, making the rocket lighter. With the first stage gone, the second stage fires up. Since the rocket is now lighter, the same amount of thrust propels it much faster and higher. This process repeats for any subsequent stages, each one taking the rocket closer to its final destination, space. Think of it as a relay race, with each stage passing the baton to the next, propelling the rocket further and faster. This ingenious method of gradual shedding of weight allows rockets to efficiently break free from Earth's gravitational pull and reach the vast expanse of space. When one stage uses up its fuel, it falls away to make the rocket lighter and faster. So the next time you witness a rocket launch, remember to appreciate the incredible engineering that goes into each of those stages, helping mankind explore the cosmos. Once rockets go super fast and high enough, they reach space. But space is not the final frontier for these high-flying machines. Despite the absence of air and the silence of the cosmos, there's still a lot of work to do. To stay in space rather than falling back to Earth or heading off into the void, rockets need to go even faster. This is where the concept of an orbit comes in. Imagine running around a circular track. If you stop running, you'll stay where you are. But in space, if a rocket stops, it will fall back to Earth. So, rockets need to keep going fast enough to stay on their track around the Earth. This is what we call an orbit. An orbit is like a constant free fall around the Earth. The rocket is falling towards the Earth, but it's also moving forward fast enough that it keeps missing it. So, in essence, it's perpetually falling but never landing. It's a delicate dance of speed and gravity, a cosmic ballet if you will. So, What happens when rockets achieve this perfect balance and settle into their orbits? Well, that depends on their mission. Some rockets are tasked with delivering satellites into orbit, which help us with everything from weather forecasting to navigation and telecommunications. Other rockets have even loftier goals. They aim to reach the International Space Station, a remarkable feat of engineering that orbits Earth every 90 minutes. Here astronauts live and work, conducting experiments that can't be done on our home planet. And then there are those rockets that go even further. They're aimed at the Moon, Mars, and beyond. These interplanetary voyages carry rovers, landers, and sometimes even humans on missions of exploration and discovery. They're the pioneers of the final frontier, pushing the boundaries of what we know about our universe. Others go even further, maybe to the Moon or Mars. These journeys represent the pinnacle of human achievement and the limitless potential of our spirit of exploration. Rockets and spaceships that carry astronauts have another important job. They're not just responsible for breaking Earth's gravitational pull and delivering these brave explorers into the cosmos. No, their mission isn't complete until they've safely returned these astronauts back to Earth. Now, this may sound simple, but it's far from it. You see, space is a vacuum devoid of air and friction, but Earth's atmosphere? That's a whole different story. As a spacecraft descends back to Earth, it has to pass through this atmosphere, and that's when things get heated, literally. As the spacecraft travels at incredibly high speeds, it collides with air molecules, generating a tremendous amount of heat. We're talking temperatures that can reach up to 3,000 degrees Fahrenheit, and that's hot enough to melt most metals, let alone the materials that make up the outer shell of a spacecraft. So how do we protect astronauts from becoming cosmic toast? The answer lies in the spacecraft's heat shield. This isn't just any shield, it's a marvel of engineering designed to withstand and dissipate the intense heat generated from re-entry. The heat shield acts like an umbrella, protecting the spacecraft and its occupants from the searing temperatures. It's made from special materials that can absorb and reflect heat, and some even ablate or wear away to carry the heat off with it. And it's not just about the heat. The shield also has to be designed to handle the pressure of re-entry. Imagine the force of a speeding truck hitting a wall, and you'll get a sense of the kind of pressure we're talking about. But despite these challenges, rockets and spaceships have been successfully returning astronauts to Earth for decades. It's a testament to human ingenuity and the relentless pursuit of knowledge and exploration. So the next time you watch a spacecraft touchdown, remember what it's gone through to safely return its precious cargo of astronauts. It's not just a journey through space, but a fiery descent through our atmosphere, made possible by the critical role of heat shields. That's why these spacecraft have special heat shields to protect them. Because without them, the journey home would be a whole lot hotter. Rockets have evolved a lot over the years. From the early days of space exploration, when rockets were single-use entities, we've made significant strides in technology and innovation. The story of rockets is in many ways the story of human curiosity, ingenuity, and our relentless pursuit of knowledge. It all began with the simple idea of propelling an object into the sky. Fast forward to today, and we're not just sending rockets to space, but we're bringing them back too. Yes, you heard that right. Reusable rockets are no longer a concept of science fiction, but a reality of our time. Enter the era of reusable rockets. These are essentially spacecraft that can be launched, land back on Earth, and then be launched again. Imagine the possibilities. This could revolutionize our approach to space travel, making it more sustainable, efficient, and cost-effective. But how do these reusable rockets work? Well, after delivering their payload into orbit, they reorient themselves and reignite certain engines to slow down. They then make a controlled vertical landing, ready to be refurbished and flown again. The implications of this technology are profound. Not only does it reduce the cost of accessing space, but it also opens up a plethora of opportunities. We could see more frequent space missions, the establishment of colonies on other planets, and even space tourism becoming a reality. And this is just the beginning. The future of space travel is bright, and it holds a myriad of possibilities. From exploring distant galaxies to finding new homes beyond our planet, the potential is truly limitless. But let's not get ahead of ourselves. While these advancements are exciting, they also come with their own set of challenges. As we continue to push the boundaries of what's possible, we must also ensure that we do so responsibly and sustainably. In the grand scheme of things, we are still at the dawn of space exploration. The rockets we have today are just the stepping stones to a future where space travel might become as commonplace as taking a flight to another country. This makes space travel more efficient, and one day it might even become as common as taking a flight to another country. Isn't it incredible how humans have created these powerful machines to explore the vastness of space? Truly, the ingenuity that has gone into rocket engineering is nothing short of awe-inspiring. These towering structures, fueled by a potent mix of chemicals, defy gravity and pierce the very fabric of our atmosphere to reach the great beyond. Throughout our journey, we've explored the intricacies of rockets, from understanding their basic structure to delving into the immense power of rocket fuel. We've learned how these machines are designed to overcome the Earth's gravitational pull. We've broken down the multi-stage process that rockets employ, shedding their weight to gain speed and reach higher into the sky. We've discovered how rockets navigate the path to space, entering into an orbit around the Earth and sometimes venturing further to the International Space Station, the Moon, Mars, and beyond. We've also learned about the challenges of returning home, the delicate dance of re-entry that requires intricate planning and execution to ensure the safety of the brave astronauts aboard. Looking ahead, we've peered into the future of space travel, where reusable rockets are no longer science fiction, but a reality. This innovation holds the promise of making space exploration more sustainable and accessible. Yet, as we marvel at these technological wonders, let's not forget the human element. Behind each rocket's journey to the stars is a team of dedicated scientists, engineers, and astronauts. Their collective knowledge, tireless work, and unwavering courage are the true marvels that make space exploration possible. So the next time you gaze up at the night sky and see that tiny speck of light moving across the darkness, remember the marvel of rockets. Remember the science, the engineering, and the human spirit that powers each journey into the cosmos. Next time you see a rocket launch or watch one on TV, you'll know exactly how they journey to the stars.